about angles. And you may think, oh, angles, I know all about angles. I've learned about them since I was a little kid. Not a big deal. Well, we want to make sure everybody understands exactly what's going on with angles. First off, an angle is always made up of two rays with a common endpoint. So here, I've got my angle, and I've got two rays that have the same endpoint, Q. And that's what makes up an angle, two rays. So things we've already talked about. Naming angles is very important. The order in which we name angles is important. We can't just put the letters in any particular order. When we name an angle, we usually use three letters to name the angle. So what we'll do is we'll use an angle symbol to start with. That's what the angle symbol looks like. So we have to use the right symbol, just like we did with segments and lines and things like that. Need the angle symbol. If I don't use the angle symbol, if I just use three letters, I could be talking about a plane, or maybe a triangle, or something else that's set up with three letters. But if I use the angle symbol, I know I'm talking about an angle. And I would name it angle P, Q, R. So starting at P, then going to Q, and then ending at R. That tells me where the angle is. I could also go the opposite way. I could call it angle R, Q, P. So starting at R, then to Q, then to P. That would be just fine. But it says, what's a third way of naming this? Since there's only one angle pictured here, I can take a shortcut and just call it angle Q. Because there is only one angle Q there. There are no additional angles that use that vertex. So I can use a shortcut. What I can't do is I can't say QPR. Why? Because if I start at Q, then go to P, then go to O, that's not the same angle, is it? So when I'm naming an angle, I have to make sure I either just use the one letter if it's a single angle, like angle Q. If I do use a three-letter name, the second point has to be the vertex of the angle. Another way I could name an angle sometimes is you see this little number 1 here inside the angle. So I could, that's often done in drawing, so we can shortcut and just call that angle 1. So that's another way of naming an angle. I could also call that angle Y, or angle X, Y, Z, or angle Z, Y, X. Those would all be legitimate names for that angle. For number 3 here, I could call that angle 2, or angle DEF, angle FED, or angle E. So naming an angle properly is pretty important. If I want to talk about the name of an angle, that's how I do it. If I want to talk about the measurement of an angle, I'm going to do this, and you see it right here. I'm going to put that little M in front of the angle symbol. That indicates the measure of angle AOB. So that little M in front of my angle symbol means now I'm talking about the measurement. Angles, just like segments, things are congruent. If I want to talk about two things being congruent, I name angles. Measurements are equal. So that whole idea of congruence and equality comes back again. Using a protractor, I'm sure you've learned how to do this many times. We place one ray along one side, the vertex at the center of the protractor. And then we read starting with the 0 and working our way up, 10, 20, 30, 40, 50, the measure of this angle. And I'd say the measure of angle AOB, or BOA for that matter, it doesn't matter, equals 140, and we're measuring in units called degrees. Now, you say, well, of course we're measuring degrees. What else do we measure angles in? That's a question you're going to have answered when you get to pre-calculus. We use other methods, other measurement systems to measure angles, sometimes other than degrees. Just the same way as in temperature. We use degrees Fahrenheit or degrees Celsius. Or we can use inches, or we can use centimeters for length, or liters or quarts for volume. We have different measurement systems, and you maybe thought the only measurement system we're ever going to have for angles is degrees, but that's not true. It is the only measurement system we'll use in geometry. So don't worry about it for geometry, but the degrees is important. These names should be pretty obvious to you, at least the first three. Acute angles measure between 0 and 90. Right angles measure exactly 90. Notice the little box here in the corner of the right angle. That indicates that it is a right angle. So if you see that little box, you may assume that that is a right angle. If you do not see the box and you just see the two lines look like they're almost a right angle, you can't make the assumption unless you're given more information. Obtuse angles are between 90 and 180. Straight angle is kind of an interesting, that might be new to you. It's exactly 180 degrees. A straight angle could also be known as opposite rays. AX, ray AX and ray AY are opposite rays. That makes a straight angle. So naming angles. You're going to be using some measurements of angles here. Fairly straightforward stuff. Again, just be careful. I want GHK, so let's find it. G to H to K. Let's highlight that one. Okay. Starts here at 0, counts up to 125. And again, maybe I'd say measure of angle GHK equals 125 degrees if I was writing this on my paper. Let's try the next one. Hooray for smartboards. JHL. So starting at J, then to H, then to L. Aha, that one's pretty easy. Measure angle JHL is 90 degrees. It's a right angle. So the first one, 125, that one was obtuse. Classify. This is right. I bet most of you are guessing the next one's going to be acute. Let's see. LHK. L to H to K. You get a little curvy there, but that's okay. Oh, this is a little different, isn't it? We didn't start at 0. We're starting at 90 and going back to 55 or up to 125. So that's up 10, up 20, up 30, 35 degrees. So measure angle LHK is 35 degrees, and sure enough, it is acute. Identify angles in the picture. What is the measure of angle EFG? Now you're saying, well, how do I know? How do I know? ADC is 140. That's this one over here. ADC is 140. EFG. Well, how do I know what that angle measure is? Well, notice the marks in the picture. You notice before we had the little tick marks for indicating congruent segments. In angles, what you'll see are little arcs. And a one arc angle is congruent to one arc angle. So that means angle G and angle B here have to be congruent because they both have just one arc. Also, the two arc angle, because not all angles the same way, a two arc angle is congruent to a two arc angle, which means it has the same measurement. So if the measure of angle ADC is 140, the measure of angle EFG, since they are congruent, also has to be 140 degrees. So again, notation. What are we doing? What does a symbol mean? What does the picture mean? What do those little markings mean? They indicate congruence, which is a nice thing for us. Angle addition postulate, and we're going to get angle bisectors, very similar to what we learned with segments, so this is really the same basic idea. Angle addition postulate says if I take, to highlight a little bit, if I take this angle right here and I add it to this angle right here, gosh, if I add those two pieces together, I get the whole thing right there. Not really that earth-shattering. As long as they aren't overlapping each other I take the two smaller pieces, add them together, no overlap, no gap, we're going to get the bigger angle. Which leads us to our next problem, which dives into a much heavier algebra concept. It says, given that measure angle LKN is 145, let's indicate that on our drawing. LKN, the whole thing is 145 degrees. Find the measure of the two smaller angles. Now, again, we've seen this before. I have two algebra expressions. The last time we did this, we were working with midpoints and bisectors, and we just set those two algebra expressions equal to each other and solved it and went on our merry way. That's not going to be the case this time. There's nothing here to indicate to me that the two angles are congruent to each other. In fact, visually, just looking at them, I'd say they aren't. But what do we know? We know that angle addition applies. I know that the measure of the first angle, 2x plus 10, plus the measure of the second angle, 4x minus 3, equals the measure of the whole thing. Aha. There's our equation. Not setting them equal, but adding them and setting them equal to a total. Now, part of you is going, well, wait a minute. How do I know which one to do? Those are two pretty simple things, but which one do I pick? Well, that's where your problem-solving skills come in. That's where you have to start saying, okay, I need to look at and analyze this picture. What's going on in this picture? Am I going to set them equal to each other, or am I going to add them up? And that's where your decision-making skills become very, very important. Once we've got that, the algebra is fairly simple. These are on the same side, so do not subtract 2x twice. That would be incorrect. We're going to combine like terms. 2x plus 4x is 6x, plus 10 minus 3 is plus 7, is 145. So we subtract 7 from both sides. 6x equals 138. And x is going to be 23. Now, are we done? X is 23. Hooray! Are we done? No. That's not, the question did not say find the value of x. It said find the measure of the two angles. So measure of angle LKM was 2x plus 10, or 46 plus 10, 56. And the measure of angle MKN, MKN is 4x minus 3, or 92 minus 3, or 89. And sure enough, when I take 89 plus 56, I get 145. It works out perfectly. Everything is happy. The world is good, and we can move on. Now, before we move on, though, I want to point out one thing. How many of you, when you looked at this picture, initially thought angle MKN was going to be 90? Because it looks like it's 90. But when we calculated it, it's actually only 89. This is a great example of when not to make an assumption. I can't assume just because that kind of looks like a right angle that it's going to be a right angle. It was close, only 1 degree away, but it is not a right angle. So do not make that assumption unless you see that little box in the corner that indicates to you that, yes, you can make that assumption. Be very careful. Here's given KLM is a straight angle. See what's going on here. So these two angles have to add up to 180. And again, you don't have to put the parentheses down. I'm doing it simply for your sake so that you can see where those numbers are coming from. That I'm just not pulling these 4 numbers out of anywhere. They're actually coming from the measurements of the angles themselves. Then we combine like terms. So 14x is 182. We add 2 to each side. Should show that. So x equals 182 divided by 14. And again, got to get my calculator out for that just to be sure. I'm sure I could, just to be quick. 13. And once again, that's not my final answer. We need to find the measures of the angles. So the measure of angle KLN is 10 times 13 minus 5, or 130 minus 5, or 125. Measure of angle NLM is 4 times 13 plus 3. That's 40 plus, it's 52 plus 3, which is 55 degrees. So we've got our measurements. Number 9 works very much the same way, except this time we're going to add them up and set them equal to 90, because this little box right there indicates that that is a right angle. I'm not going to bore you by running through that entire example again, but you get the idea. We're going to add them and set them equal to 90. Now, bisectors. Just like segments have bisectors, angles also have bisectors. Now, bisectors and angles have to be rays or lines. There are no midpoints in angles. That wouldn't make sense, but we do have bisectors. It says QS bisects angle PQR, and angle PQS is 24. Find the measure of angle PQR. You're like, what in the world? This is really weird. Where's our picture? Well, we're going to have to draw it. It says QS bisects angle PQR, and angle PQS is 24 degrees. So if PQS is only 24 degrees, PQR is going to be not that big. So I'm just going to go ahead and draw an angle here. And Q I know is my vertex. P and R are my other 2 points. I'm not sure if it looks exactly like that, but that's a model. We're just going to build a model of it. QS is the bisector. What does that mean? It's going right smack down the middle here. In this case, since they're told it's a bisector, it means those two are perfectly congruent to each other. Now, what are we given? Measure of angle PQS is 24 degrees. So this must also be 24 degrees. Measure of angle PQR in that case has to be 48 degrees. So now we get the idea of an angle bisector, where the ray down the middle actually does split it equally. Here, LN was not a bisector of that straight angle. It didn't split it equal. Here, FH, right here, FH is not a bisector. It's not splitting it equally. But here, QS is a bisector. It is splitting it equally. Here's another example. Angle MNP is a straight angle, and Q bisects MMP. Draw them, then use arcs to measure congruent angles in your diagram. Find the angle measures of these congruent angles. All right, so let's start out. Let's draw the picture. Angle MNP is a straight angle. Well, that's easy to draw. Vertex is at N, and M and P. There's MMP as a straight angle. And Q bisects it. Well, bisects it means splitting it exactly in half. So we've gone ahead and drawn that. Use arcs to measure the congruent angle. So if this is a bisector, that means that this is congruent to that. But MMP is a straight angle, which means it measures what? Yeah, 180. And if it's split in equally, each of these is actually 90. And 90, meaning these are both right angles. So if a straight angle is bisected, I get 2 right angles. Oh, that's kind of nice. There's my picture. So we're going to be working in class a lot with the idea of angles now. And we threw a lot of things in this section. There's a lot of work with angles. But I think you'll find it pretty straightforward. And again, we'll all be together in class to help each other and make sure we can get through this assignment with no problem at all.